For any triangle ABC, prove the following. Let us begin. First, we're going to go through some terminologies. Let's say we have a triangle with vertices A, B and C. The sides opposite to angle A, angle B and angle C are represented by A, B and C in lowercase. If we now take the sum of the three sides, that's going to give us the perimeter of the triangle. And if we divide it by 2, that's going to give us the semi-perimeter, which is denoted by the letter S in lowercase. So we'll start the problem from the left hand side. So on the left hand side, we have here A multiplied to cosine squared C over 2 minus cosine squared B over 2. Now this is standard half angle formula for cosine C over 2 and cosine B over 2. Let's note them down. We know that cosine of the angle, let's start with B over 2. So that's given by the square root of S multiplied to S minus the side that is opposite to angle B. So side opposite to angle B, so that's going to be B. And we're going to divide it by the product of the sides that are adjacent to angle B. So that's going to be A and C. Now we have division by the product AC. Similarly, we can define the cosine of angle C over 2. This is going to be given by square root of S multiplied to S minus the side opposite to angle C. So that's going to be simply C divided by the product of the adjacent sides. So that's AB. Let's use this value. Now we will have on the left hand side A multiplied to, so we have to square cosine of C over 2. So that's going to give us S multiplied to S minus C divided by AB minus cosine squared B over 2. So squaring it gives us S times S minus B divided by AC. Fine. Now we're going to distribute A with each of the two terms within the parentheses. So that's going to give us S multiplied to S minus C divided by B. So here A and A gets factored out. Similarly, in the second term, we have S multiplied to S minus B divided by C. Fine. Now let's combine the two terms. So here in the new denominator, we have BC. Then in the numerator, we will have S multiplied to C times S minus C minus S times B multiplied to S minus B. So let's now simplify. This is going to give us S squared C minus SC squared minus S squared B plus SB squared whole divided by BC. Now what we'll do, we'll take SB squared and negative SS squared. We're going to combine them. So we get SB squared minus SC squared. Let this be a single term. And then we're going to combine the remaining two terms, S squared B and S squared 3, but we're going to take negative as the common factor such that we have S squared B minus S squared C whole divided by BC. Fine. Now let's further simplify. So we can factor out S. So S gets multiplied to B squared minus C squared minus. So from here we can take S squared as the common factor. So we have S squared multiplied to B minus C whole divided by BC. Now we have S multiplied to B squared minus C squared. So that's the difference of two squares. This is going to get factorized to give us B minus C times B plus C minus S squared multiplied to B minus C whole divided by BC. Now we have two terms in the numerator. Now from each of the two terms, we are going to take S multiplied to B minus C as the common factor. So that means this will get multiplied to B plus C minus S whole divided by BC. Okay, now we can manipulate B plus C minus A because we know that A plus B plus C divided by 2, that's equals to the semi-perimeter, or we can say that will be simply equals to 2 times S. Or in other words, we can say if we take B plus C minus S, and this is going to be left with S minus A. Fine. So we can substitute B plus C minus A with S minus A. So this will be now S multiplied to B minus C times S minus A whole divided by BC. That means we now have, we're going to take B minus C as the common factor. So B minus C gets multiplied to S times S minus A divided by BC. However, what we'll do, we can further rewrite it as, we'll take the square root and then square it without the change in meaning. But by doing so, we can replace the terms inside the parentheses with cosine of A over 2. And then we have to square this value. And this is exactly the expression on the right hand side. So thus we have successfully verified that the left hand side is equals to the right hand side. So let's check the problem one more time. So b minus e multiplied to cosine squared A over 2 on the right hand side. Yeah, so we have b minus e multiplied to cosine squared A over 2 on the right hand side.